Some of it. Like I question.
Oh, goodness. 2 of your 5 questions, you only have 5 homework questions today. 2 of them talk about maximum value. And the big idea is, again, why are we doing stuff like this, symmetry and stuff like this, is it's to help you with your graph. Because if you know what the biggest value is, then you know if your graph at least is reasonable. And the nice thing is, you can tell what the maximum value is because there's a trig function in there. Do we know what the biggest value we can ever get out of cosine is? 1. Do you agree with me on that? We know that cosine is stuck between, it has to be smaller than or equal to 1, and what's the smallest it can ever be? -1. And it just goes in between that, right? The same thing with sine. Sine is the same way. So you can figure out what the maximum or even the minimum value of your graph is before you even start to graph it by just thinking the biggest that this can ever be is 1. So do you agree that the biggest that r could ever be would be 2 plus 2 times 1, which happens to be 4? Is that required to make a graph? No, but it's helpful because if I know my graph shouldn't go past 4, if I'm making my chart and for some reason I get a value of r past 4, then I know something's gone wrong. On your homework today, they ask you to find the maximum value and where it occurs. And so where it occurs is pretty easy because where does cosine equal 1? Maybe easy. At 0. You could give 2 pi as an answer. You could give 4 pi as an answer, as long as it's where cosine equals 1. I just say 0. So we could say that this has a max of 4 at theta equals 0. The one thing I do want to caution you about is be careful. We're going to do one in a minute. We're going to graph number 15, and we're going to think the maximum of it. If this was a minus sign, that's going to kind of change things because now if you plug 1 in there, that's not going to be the biggest value. But it's always going to either be plugging in what makes it 1 or what makes it -1, and we'll look at this next one in a minute to think about that. But just be aware that sine and cosine, the biggest they can be is 1, the smallest they can be is -1, and so that helps you find your maximum value. And so what we're going to do is we're going to graph number 15 from your homework from yesterday. You did not have to graph number 15. But this is the equation for number 15, and we're going to graph on the graph paper that I gave you yesterday. You only have 3 to graph for homework tonight, so using up one of these little circles is going to be okay. Yeah. Oh, you don't have a graph paper. You left me 2 of them. So Chloe, could you compete on the basketball team if you really wanted to, since you go there for a class today?
I guess I could find out.
That would be awkward if you were like on our team for part of the time and then we did cancel.
I don't know, I might have to be able to take it.
Ethan goes to Cloverdale and he takes calculus and physics here, and they always discuss with him that he could play sports here if he wanted to. I said, I don't know. I think he goes here. He goes to Cloverdale more. I think he has to play Cloverdale, but they decided that he really wanted to. And probably like he's on the senior shirt. Let me tell you, Katie and Kimberly were very upset that Ethan's name was on the senior shirt, and I said it's just because they just printed off Harmony. Like every senior on Harmony, they just put off a shirt, and they put it on their list that he goes to Cloverdale. And I said I think he's just as offended being on our shirt as you are that he's on there. So we're going to just graph this by making a chart, but I do want to talk about the max min thing for a minute. If I try to find the maximum value on this, we do it just like the last one. If I wanted to think about the max value, I'd be like, oh, I can plug 1 in here, and I would get 4 minus 3. You with me on that? Which would be r equals 1. Is that going to be the maximum value for this one? Is that the biggest that r is ever going to get? You see how that negative kind of throws off what we're doing? Because what if I plugged in -1 for cosine? Can cosine be -1? So what if I tried -1? I get a bigger number, because those negatives become positives, and I actually get r equals 7.
So that's our main.
Yeah, so this actually happens to be our minimum, because it's switched around on that. You with me on that?
I mean, it's our max, like taking a cosine, but it's our minimum on the graph.
Yes.
So, which would you like me to call it?
Well, for this, if the question said find the maximum value of r, we would have to say the maximum is r equals 7, because that's a bigger r than this is.
So the maximum is the minimum.
It is. So in second hour, we were working on the homework, and they're like, how would I know? How do I know whether I would plug in 1 or I would plug in -1? Well, it's pretty much, if it's a subtraction sign, you're going to plug in -1, because those are going to, it's going to be the opposite of what you think. But it's always going to be either where cosine theta equals 1 or cosine theta equals -1, which means it's always going to happen at either 0 or at pi for cosine. And you just need to kind of look at it. There's only two options. It's either going to be when you plug in 1 or you plug in -1. And so just be aware that it's not always what the max value of cosine is, because the negative can throw it off. Does that make sense? So I just like to throw that out there. I'm telling you, the two on your homework that you have to do maximum ons are both pluses, positive signs, and so don't overthink it too much. But I just want to remind you that on this one, the maximum actually occurs when theta equals pi, not when theta equals 0. And what if there was a sign in there? What would be the angle values where sine could be a maximum? Where does sine get its biggest and smallest values from? When does sine equal 1? Pi halves? When does sine equal -1? 3 pi halves. So those would be your two options for sine. So I just like to remind you of that, okay? Don't stress too much about it. What we're going to do is we're going to graph this. You don't even have to do this to graph. I just wanted to show you. Change it up on there, making thetas first. Thetas and r's. We already did this one, so we might as well put that one up there. We know at pi, I'm going to get an r7. At what theta would I get an r of 1? Okay, sorry, I'll just go backwards. I was trying to just use what we did already. If I plug 0 in for cosine, do I get 1 for r? That's what we just did over there. 1. What else should I do? I don't know. Let's pick some points. See what happens. If I pick pi thirds, trying to pick ones I can do nice in my head. What is the cosine of pi thirds? 1/2. So then that would be 4 minus 3 times 1/2, or 4 minus 1/2. So that's 2/2. Look at me using decimals. Again, you can do these all on your calculator. Make sure you're in radian mode. What else do you want to pick? You know. 3 pi halves? Oh my goodness. Okay.
You don't have to pick that.
How about, let's say the top half. Let's do pi halves. Because 3 pi halves and pi halves should give us the same answer, I would think. Because what is the cosine of pi halves or 3 pi halves? 0. So 4 minus 0 gives you 4. If you want to put 3 pi halves, we already know that. But what did you get for 15? Did you get that it was symmetric with anything? The polar axis. So let me go to my graph here. This is where symmetry is nice. If I know it's symmetric about the polar axis, does that mean whatever points I get up here, I can automatically put the same ones down here? That's why we like symmetry, because you don't have to pick so many points. But we could pick 3 pi halves, and it's also going to give us 4. What about should we go over here, or you want to keep over here? Go over here. Let's do pi 6. Pi 6 isn't very pretty. It's a square root, because the cosine of pi 6 is squared 3 over 2, right? I'm going to do that one on my calculator. 4 minus 3 times cosine of pi over 6. You can just type that in your calculator. 1.4. What about when I go over here to quadrant 2, cosine's now going to be negative, right? And so we can't just flip it straight over because of all this subtraction that we have going on here. We're actually going to get bigger numbers over here because think about if cosine is negative, we're going to take a negative times a negative and then add 4. We're going to get some pretty big numbers. That's how we're going to get 7 over there. So let's pick like 2 pi thirds. The cosine of 2 pi thirds is negative 1/2, right? So now I have 4 minus 3 times negative 1/2. That's going to be a positive number, right? I forget what it is, 5 1/2? 5 1/2. Let's graph that and see if we need more points. See if you believe me or not. You don't have 7 circles on your graph, right? So let's just, I think you only have 6. 1, 2, 3, 4, 5, 6, 7. I'm just going to make it that out there. So at pi, 7. At 0, it's at 1. At pi thirds, make sure you get the right line here. Pi thirds is at 2 1/2. At pi halves, it's at 4. 1, 2, 3, 4. At pi sixths, it's at 1.4, so I'm going to say that's about right there. And at 2 pi thirds, that's right here, it's at 1, 2, 3, 4, 5 1/2. If it helps to draw in your pi thirds, remember this is counting by pi 12ths, and so there's some extra lines in there from our normal unit circle. Yes. Oh, you're right, thanks. Telling you to be careful when they're 90 or wrong. 1.4. Just kidding. Here's what's nice, because you already did number 15 and you know that it's symmetric about the polar axis, that we can take all these points and we can flip them down. So that's where if you want to think about your symmetry today. Some people in second hour said, did I have to show any work on my symmetry? Because I kind of just looked at it to see if it would change. No work needed. That's why it's just nice if you know the rules of what you plug in there to see if it's symmetric. So because this is symmetric, I'm going to come down here and say that this is also at 1.4, and at the pi thirds one, that's going to be at 2.5. And at pi halves and 3 pi halves, it's going to be at -4. And at the thirds down here, so would that be 4 pi thirds, it's going to be at 1, 2, 3, 4, 5 1/2, like this. And then if you're not sure, you can pick more. Last hour, I just said, let's connect this. And someone said, how do you know it doesn't come back in at some point? How do you know it's just going to connect around? And use what you know about cosine. If this is getting more and more negative, closer to -1, like this is going to be negative square root of 3 over 2 when you do the 5 pi 6. When you take negative square root of 3 over 2 times -3, you're going to get another negative number times a negative, which is a positive, and it's going to just keep getting bigger. But if you're not sure, then just make more points and graph it. But again, remember, smooth curve when we connect this. So let's see if we can connect this and make this sort of look like it's supposed to look. Kind of. Does that kind of look like anything? A blob? Maybe kind of, sort of like a heart, kind of, huh? That looks like a heart, right? Like it kind of curves in like a little heart, like a little dimple. It's a heart. No, here's why I'm trying to get you to say heart. Someone in second hour said heart, so maybe mine was better in second hour. This is called a cardioid. That's the official name of this type of graph. So I try to get you to say heart because you can think of cardio, cardiac, heart, nothing. Cardioid. It's a heart shape. That's the type of graph we're going to learn about. So sometimes we have rose curves. Sometimes we have circles. Sometimes we have cardioids. We have another graph called a limacon. That's exciting, right? That's not, you just got to know that one. On your homework today, you have 3 of these to graph. Not 3 of these. 1 of these, and then the other 2 are pretty simple, hopefully, to graph. And you even have time to work. This is all my notes today. What do you think about that? You're just finishing the homework from yesterday, which this is what's left. So I'm calling this 5-1 day 1B. But my suggestion is just do it all together. There's 2 of them that you could do where you did your test for symmetry because that's just maxes. And then that's 21 and 22. And then 25, 28, and 32 are graphs. Do those on your red graphs paper that I gave you. I'll tell you 32 is like the one we just did. It should be a cardioid when you're done. The other 2, I'm not going to tell you, but they should be pretty easy to do. So one of them might just be a line. So don't overthink that one. Yeah, it's 6.5. Oh, thanks. What am I saying? 5.1. Sometimes I just make things up. 6.5. Probably 5, right? Sometimes I just need someone to be my little personal assistant and get all my numbers right. The sad thing is I can't even blame that on another class because they're not in chapter 5 of any class. So. 6-5, day 1. Tomorrow we're doing an activity. Thursday we are doing day 2 of 6-5. Are there anyone in here? Sam, you're going to be going on Thursday on a field trip? We're doing 6-5 day 2, so you'll want to get some notes from me or when you get back or something, okay? Because it's kind of a big day putting it all together. You'll be watching a play. Do you even know what play you're seeing? I asked Katie Hacker what you're seeing, and she said she has no idea. No one knows.